Good morning, sir. Welcome. Good morning, children. Welcome to Price webinar classes. This is RaviLal, Engineering Chemistry, TSRJC, Nerella. Okay. Today we are going to discuss the topic second year chemistry, third unit, physical chemistry. The chapter name is Electrochemistry and Chemical Kinetics. This chapter is very important in physical chemistry, electrochemistry and chemical kinetics. IPE weightage 4+8, total 12 marks. So in this chapter, electrochemistry, electrochemical cells, second one galvanic cells, Nernst equation, conductance of electrolytic solution, fifth one is electrolytic cell and electrolysis, sixth one is batteries, seventh one fuel cells, eighth one is corrosion. In this unit's main topics, electrochemistry, introduction. What is electrochemistry? Listen here carefully, student. What is electrochemistry? Electrochemistry is the study of production of electricity from energy released during spontaneous chemical reaction and the use of electrical energy to bring about chemical transformation, including non-spontaneous process. Here, electrochemistry deals with the use of chemical reactions to produce electricity. Okay, student, and the use of electricity to produce chemical change. Here, what is that electrochemistry? It is study of production of electricity from energy released during spontaneous chemical reaction. Here, what is spontaneous chemical reaction? Without involvement of any external agency. Here, picture. This is chemical energy converted into electrical energy. See the diagram clearly. Chemical energy converted into electrical energy. Here, electrochemistry, the subject is the subject interest and importance of both theoretical and practical aspects. Here, batteries and fuel cells convert chemical energy into electrical energy. Batteries and fuel cells. Electrochemistry is important for creating new technologies that are eco-friendly because of more efficient and less pollutant. Electrochemical methods are used in the industry for the preparation, manufacture of many important chemicals. Okay, student, such as sodium hydroxide, chlorine, fluorine, and many metals such as alkali metals and alkaline earth metals, aluminium. Here, the electrochemistry important new technologies. Thus, the study of electrochemistry are eco-friendly. Electrochemistry, electrochemical cells. What is electrochemical cells? Listen carefully. Electrochemical cells. Here, electrochemical cell, a device which converts chemical energy from spontaneous redox reaction is called electrochemical cells. Once again, a device which converts chemical energy from spontaneous redox reaction into electrical energy is called electrochemical cell. These are also called galvanic cell or voltaic cell. What is a redox reaction? Redox reaction means involving oxidation of reaction as well as reduction of reaction. Cell reaction or spontaneous reaction. What is spontaneous reaction, student? Without involvement of any external agency. Here, see that these are also called galvanic cell or voltaic cell. Here in this cell, the Gibbs energy of spontaneous redox reaction is converted into electrical energy. Delta G is equal to minus NFE. Here, where delta G means Gibbs energy, N moles of electrons. F means Faraday's constant. E means standard cell potential. Here in this device, the Gibbs energy of the spontaneous redox reaction is converted into electrical work, which may be used running of motor and other electrical gadgets like heater, fan, and geyser. See that used running motors or other electronic gadgets like heater and fans and geysers, etc. Daniel cell is an example of galvanic cell. Daniel cell is an example of galvanic cell. In the cell electrodes named, a galvanic cell consists of two such electrodes immersed in solution of their respective salts. The two electrodes are connected externally by a metallic wire through a voltmeter and switch internally by a salt bridge. When circuit is completed by closing the switch, a redox reaction occurs in which one of electrodes undergo oxidation while the other undergoes reduction. Here the cell reaction Daniel cell Zn plus Cu plus 2 gives rise to Zn plus 2 plus Cu. Here zinc is oxidation reaction. Here Zn plus at anode position, zinc Zn gives rise to Zn plus 2 plus 2 electrons. Oxidation reaction. Oxidation reaction means loss of electron. Loss of electrons or oxidation number increased side. Zn gives rise to Zn plus 2. These reaction occurs in two different portions of the Daniel cell. The reduction half reaction occurs on the copper electrode, while the oxidation half reactions occur on the zinc electrode. These are called half cells or redox couples. Here two in this galvanic cell, one is oxidation reaction half reaction, second one is reduction half reaction. Oxidation half reaction at anode, reduction half reaction at cathode position. Oxidation of reaction means loss of electron. Reduction of reaction means gain of electrons. In these two, electrons are called half cells or redox couples. Here, each half cells consist of metal rod electrode dipped in an electrode. Here, zinc rod dipped in zinc dipped in copper sulfate solution. Zinc is a zinc left hand side. Left hand side is oxidation half reaction. Right hand side reduction half reaction. Left hand side is anode. Right hand side is cathode. Here two cells. These two half cells are connected by a metallic wire through a voltmeter and switch externally. See the diagram carefully. The two half cells are connected by metallic wire with through a voltmeter and switch externally. Here, the electrolytes of two half cells are connected internally through a salt bridge. Internally through a salt bridge. Salt bridge is a very good role in galvanic cell. Very good role because of it will close the circuit of the cell. The accumulation of the prevent the corresponding anion in the cathodic half cells and cation in the anodic half cells. The salt bridge, it will allow through only ion to pass through, but not solution. Major roles of the salt bridge in galvanic cell. Okay, student. Salt bridge is very good role in galvanic cell because of it will close the circuit of the cell. Here, reduction half cell. Reduction half reaction. Reduction half reaction means gain of electrons at cathode position. Copper Cu plus 2 electron gives rise to Cu. Oxidation half reaction. Oxidation half reaction means okay, loss of electrons. Oxidation means loss of electron at anode position. Zinc gives rise to Zn plus 2 plus 2 electron. Overall reaction Zn plus Cu plus 2 gives rise to Cu plus Zn plus 2. Here, electrochemical cells working process. there is a tendency of metal ion from the solution to get deposited on the metal electrode, trying to get it positive charged. At the same time, metal atoms of electrodes have a tendency to go into the solution and make it negative charge. Once again, positive charge and negative charge. What is positive charge? There is a tendency of metal ion from the solution to get deposited on the metal electrode. Deposited on the metal electrode, trying to make it positive charged. At the same time, metal atom electrode have a tendency to go into the solution and make it negative charged. Positive charge and negative charged in the cell. At equilibrium, there is separation of these two types of charges. Hence, depending on the tendencies of the two opposing reactions, the electrode may be positively charged or negatively charged with respect to the solution. Here, okay, at equilibrium, there is a separation of two types of charges, a positive charge and negative charge with respect to the solution. Electrochemical cell, a potential difference developed between the electrode and electrolyte solution is called electrode potential. What is electrode potential, student? Electrode potential means difference between a potential difference between electrodes and electrolyte solution is called electrode potential. At each electrode and electrolyte interface, there is tendency of metal ion from the solution to get deposited on the metal electrode. In galvanic cell, the oxidation half cell is called anode and it has the half cell is called cathode and it has positive potential with respect to solution. Here, electrochemical cell, see the diagram, opposite charged ion and adjacent to the surface diffuse layer. So a potential difference between electrode and electrolyte solution, which is known as electrode potential. The exact potential difference equilibrium depends on the nature of metal, its ion and concentration of ion and temperature. According to present IUPAC conversions, half cell reaction always reduction half reaction and their potential are represented by reduction potential. It may be noted that opposite charged ion and once again two electrode, zinc is anode, copper cathode, zinc anode, oxidation loss of electron, Zn gives rise to Zn plus 2 electron. Copper is reduction. Reduction means gain of electron. So Cu plus 2 electron gives rise to Cu. Two electrodes connected into salt bridge. Number of galvanic cell can be constructed on the same pattern of Daniell cell by taking combination of any two different half cell. Okay, student, that is the galvanic cell. Galvanic cell means chemical energy convert into electrical energy of a spontaneous redox reaction into electrical energy. Okay, IUPAC convention. IUPAC convention, write the anode on the left hand side. Anode on the left hand side and the cathode on the right hand side by putting a vertical line in between the symbol of the metal and formula of the electrolyte in the solution. IUPAC nomenclature generally write cathode left hand side, anode right hand side, and put a double vertical line in between the solution. Double vertical line between the solution to electrode solution. This indicates the connecting salt bridge. This indicates the connecting salt bridge. Under these convention, the EMF of the cell is always positive. This is given the difference in potential of the right hand electrode and left hand electrode. Here, anode and cathode. Anode is left hand side, cathode is the right hand side. Metal dipped in electrolyte solution, double line vertical and electrolyte and metal. So where R mean reactant, P mean product. Here E cell is equal to E right hand side minus E left hand side. So the cell reaction Zn plus Cu plus 2 gives rise to Zn plus 2 plus Cu. Electrode, zinc metal in electrolyte solution Zn plus 2, salt bit Cu plus 2. Here right hand side, left hand side oxidation of reaction, right hand side reduction of reaction. Write the cell reaction taking place in the cell. Okay, Cu plus 2, salt bridge, Ag plus Ag. Here cell reaction Cu plus 2 Ag plus gives rise to Cu plus 2 plus 2 Ag. Cell EMF. EMF means electromotive force. Electromotive force. The EMF the cell is always this the difference in potential of the right hand electrode and the left hand electrode. So E cell is equal to E right hand side minus E left hand side of the cell. So standard reduction potential. What is standard reduction potential? SRP. When the concentration of the electroactive species involved in a half cell is unity, then the electrode potential known as standard electrode potential. Once again, student, what is a standard reduction potential? Standard reduction potential means when the concentration of the electroactive species involved in a half cell is unity, then the electrode potential known as standard electrode potential, or standard reduction potential. A substandard reduction potential of half cell measured with the help of standard hydrogen electrode. Standard reduction potential is measured with the help of the standard hydrogen electrode, SHE. What is standard hydrogen electrode? Standard hydrogen electrode is a reference electrode. The standard hydrogen electrode construction. Standard hydrogen electrode, here see that the potential of an electrode cannot be accurately directly measured. It is not possible to the connect measuring device to the solution of electrode, as it may be led to another equilibrium along with the existing one. The problem can be overcome if electrode is connected to another electrode of known potential, such as electrode is known as reference electrode. So the reference electrode from the measure EMF of the potential of the electrode can be obtained by the subtracting the potential of reference electrode construction. It consists of platinum electrode coated with platinum black. The electrode is dipped in a solution of acid, usually 1 molar HCl, and pure H2 gas bubbled through it at atmospheric pressure, 1 bar pressure. Okay, students. The commonly used reference electrode is the hydrogen electrode. The EMF of standard hydrogen electrode is taken as 0.0 volt at all temperature. As standard hydrogen electrode consists of a platinum coated platinum electrode coated with platinum black. The electrode is dipped in 1 mole HCl, pure H2 gas at 1 bar pressure is continuously bubbled through it the solution at temperature 298 Kelvin temperature. The oxidation or reduction in standard hydrogen electrode. See the diagram. The the oxidation or reduction in the standard hydrogen electrode takes place at platinum electrode. Hence, it can act as anode as well as cathode and may be represented as these standard hydrogen electrode platinum H2 H plus at 298 Kelvin temperature. The EMF of the cell by connecting standard hydrogen electrode with other half cell. E naught is equal to E naught right hand side minus reduction minus E naught left hand side. So at 298 Kelvin, EMF the cell constructed by taking standard hydrogen electrode as anode reference half cell and other half cell as cathode. given gives the reduction potential of the other half cell if the concentration of the oxidized and the reduced from the species of right hand half cells are unity. Then the cell EMF is equal to the standard hydrogen electrode. So potential is given cell E naught is equal to E naught right hand side minus E naught left hand side. So the presentation of standard hydrogen electrode as left hand side is 0. The standard hydrogen electrode is 0. E naught is equal to E right hand side. Case number 2. E naught R is equal to 0. The standard hydrogen electrode is 0. E naught is equal to minus E naught L left hand side. Nernst equation. What is Nernst equation? Okay, student, listen carefully. Nernst equation. Here it has been pointed out earlier that the tendency of metal to lose electron or tendency of ion gain of electrons depend upon the concentration of ion in solution. At the same time, the tendency of to lose or gain electron is expressed in terms of electrode potential. The value of electrode potential, therefore, changes the various in the concentration of ions. The quantitative relationship between concentration of ions and electrode potential is given by Nernst equation. So the equation which represents the depends of single electrode potential on the concentration of electrolyte solution and temperature is called Nernst equation. Once again, the equation which represents the dependence of single electrode potential on the concentration of electrolyte solution and temperature is called Nernst equation. E is equal to E naught minus RT by NF log product molar concentration by reactant molar concentration. Single electrodes are two types. Number one, metallic electrodes. Number two, non-metallic electrodes. Nernst equation for metallic electrodes. Nernst equation for metallic electrodes, half cell equation or chemical reaction. See that the reaction, okay, student. N plus N electrons gives rise to M. The electrode potential at any concentration measured with the respect to standard hydrogen electrode is represented by E is equal to E naught minus RT by NF log product molar concentration metal product molar concentration by reactant molar concentration. Reactant molar concentration M power N plus. But concentration of solid molar metal concentration is solid is taken as a 1. So the equation is E is equal to E naught minus RT by NF log 1 by Mn plus, or E is equal to E naught plus RT by NF log Mn plus, where E is equal to electrode potential. E naught is equal to standard electrode potential. R means gas constant, its value 8.314 joules per Kelvin per mole. T means temperature in Kelvin scale. N plus means molar concentration of ions. N, small n means number of electron gained. F means Faraday constant, 96,487 coulomb per mole. Molar concentration of metal. This equation is commonly known as Nernst equation for metallic electrode. Nernst equation metallic electrode by substituting Mn plus is equal to C, R is equal to 8.314 joule per mole per Kelvin, T is equal to 298 Kelvin, F is equal to 96,500 coulombs or 96,487 coulombs in the above equation. So for non-metallic electrode, Nernst equation, half cell equation or chemical reaction X plus N electron gives rise to X N minus. The electrode potential at any concentration measured with respect to standard hydrogen electrode is represented by E is equal to E naught minus RT by NF log product molar concentration by reactant molar concentration. Product molar concentration is X power N minus by X molar concentration. Here, the concentration of solid, liquid, and gases at 1 bar pressure is taken to be unity. So, the reactant molar concentration is equal to 1. For the Nernst equation, non-metallic electrode, E is equal to E naught minus RT by NF log X N minus molar concentration. By subtracting X N minus is equal to C molar concentration of product molar concentration. R is equal to, R means gas constant, 8.314 joule per mole per Kelvin. T absolute temperature in Kelvin scale 298 Kelvin. F means Faraday constant. The constant is 96,487 coulomb per mole. So in the above equation, that is the Nernst equation for metallic electrodes and non-metallic electrode. Question number 1. The potential of hydrogen electrode. The potential of hydrogen electrode in constant with solution whose pH is equal to 10. Okay. The reduction of reaction of hydrogen electrode 2H plus 2 electron gives rise to H2. N is equal to 2. N is equal to 2. pH is equal to 10. So H plus concentration is equal to 10 to the power of minus 10. E is equal to question mark. H plus electron gives rise to half H2. So the solution is E is equal to, the formula is 2.303 RT by NF log H plus molar concentration. So 0.059 by 1 log 10 to the power of minus 10. N is equal to 1. Therefore, 0.059 log 10 to the power of minus 10 is equal to minus 10 into log 10. That is answer minus 0.59 volt. This is the calculate the potential of hydrogen electrode in contact with the solution whose pH is equal to 10. Next question. Represent the cell in which the following reaction takes place. Mg plus 2Ag molar concentration is 0.0001 mole gives rise to Mg plus 2 molar concentration 0.001 mole plus 2Ag. Calculate its E cell if E naught cell is equal to 3.17. Cell represent as per the given cell reaction, oxidation occurs at the Mg electrode Mg plus 2, hence it acts as a anode, whereas reduction occurs Ag plus electrode, hence it acts as a cathode. Therefore, cell represented as Mg electrode Mg plus 2 salt bridge Ag plus Ag. Cell reaction Mg plus 2Ag gives rise to Mg plus 2 plus 2Ag. Here N is equal to 2. E naught cell is equal to 3.17. The formula is E cell is equal to E naught minus 0.059 by N log product molar concentration by reactant molar concentration. E naught cell is equal to 3.17 minus 0.059 by 2 log Mg plus 2 molar concentration already is given in the question 0.001 by Ag plus molar concentration 0.001 power 2. So simplify the problem. The answer is E cell is equal to 3.0518 volt. Next, Nernst equation for cell. Platinum H2 H plus. For example, small a plus b gives rise to small c, capital C plus small d, capital D. Nernst equation is E cell is equal to E naught cell minus RT by NF log Q. Q means equilibrium constant. So E naught cell minus RT by NF log Q means number of molar product molar concentration by reactant molar concentration. So that equal to log E naught minus E is equal to E naught minus RT by NF log product molar concentration by reactant molar concentration. The standard potential of some electrodes. Standard potential of some electrodes are as follows. Arrange the metals in an increasing order of their reducing power. Here number 1, K plus K is equal to minus 2.93 volt. Number 2, Ag plus electrode Ag is equal to 0.80 volt. Cu plus 2, Cu that equal to 0.34 volt. Mg plus 2 electrode Mg minus 2.37 volt. Chromium Cr plus 3 electrode Cr is equal to minus 0.74 volt. Fe plus 2 electrode Fe that equal to minus 0.44 volt. What is standard electrode potential chemical series? It means different electrodes have different standard electrode potential. Okay, the standard electrode potential for some electrodes are negative, while some other values are positive. These electrodes can be at values. The sequence arrangement of various electrode in order of increasing standard electrode potential is called electrochemical series. Suppose a negative E naught means the redox couple is stronger reducing agent. Okay, the positive E naught means the redox couples is weaker reducing agent. Here see that fluorine is the highest in the table, indicating a fluorine gas maximum tendency to get reduced fluoride ion. Therefore, fluorine is a strongest oxidizing agent and fluoride ion is a weakest reducing agent. Here, lithium has the highest negative electrode potential, indicating lithium ion is weakest oxidizing agent, while lithium metal is the most powerful reducing agent in an aqueous solution. Here, some examples, some electrodes given the it values arranging of increasing order of reducing power. So, number 1, here Ag positive values are Ag plus electrodes, copper electrodes, and iron electrodes. Fe plus 2 electrode. Fe plus 2 is negative electrode. Negative chromium electrodes and magnesium electrode are also negative. Potassium also negative. The arranging order of Ag is less than Cu is less than Fe is less than chromium is less than magnesium is less than K. So higher in the electrochemical series, highest lithium has the highest negative electrode. Lithium has the highest negative electrode, weakest oxidizing agent, and it is the most powerful reducing agent. Lithium. Fluorine has highest positive electrode, so it has a fluorine